In today's lesson, we're going to talk about what is meant by being a distance from a point to a line, as well as how to prove that lines are perpendicular. If you notice in the first statement, it tells us that the distance from a point to a line is the length of the perpendicular segment from the point to that line. All this means is if I have a point and a line, so we have this line and we have a point up here. Anytime you're asked to find the distance from a point to a line, it is referring to this perpendicular distance. There are many distances, but when it wants the distance, it's referring to that perpendicular distance. And this perpendicular distance is actually the shortest distance. So once again, if you are working a problem and it's asking you for the distance from a point to a line, it means the shortest distance, and that will always be this perpendicular segment's length. This next theorem shows us a way that we can prove that lines are perpendicular even if we don't know we have a right angle. And what it tells us, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. What that means is if I happen to know that angle 1 is congruent to angle 2, then what I can say is that those lines G and H will be perpendicular, even though I didn't know that I had a right angle. Another way that we can prove that lines are perpendicular has to do with this statement. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So what this means is, if I know that I have two lines that are parallel, such as line H and line J, and I know that line K is perpendicular to one of those lines, then what I can say is that line K has to be perpendicular to the other parallel line. And this is what we're saying. We're saying that if line H happens to be parallel to line J, and we know that line K is perpendicular to line H, then that means that line K would also be perpendicular to line J. And finally, our last statement tells us that in a plane, if two lines happen to be perpendicular to the same line, then I can say that those lines will be parallel. So in other words, it's telling us that if I know that line M is perpendicular to line P, and I know that line N is also perpendicular to line P, then I can say that line M will be parallel to line N. These will be the conditionals that we will be using in today's lesson to determine whether or not we have enough information to prove that lines will either be parallel or perpendicular.